So in the previous video, I talked about how that seemingly easy looking function was pretty nasty. So what can we do? We can use some algebra to save us. All right, so first thing is let's show that x minus 2 sine of x equals 0 can be rewritten this way. So if I wanted to get this, well, let me do a couple of things, right? So let me just say that x is equal to 2 times the sine of x, right? I can add it over to both sides. Then something else I can do, only because I can kind of see that I want to have like a 2 over x, maybe I just say I'm going to divide both sides by 2. Right, so I'd get x over 2 would equal the sine of x. This 2 over x is the reciprocal of x over 2. So a very important but commonly, I guess not commonly used operation is reciprocation. So if I reciprocate both sides, if I flip both sides, I would get 2 over x is equal to 1 over the sine of x. And then what could I do? I could bring this 1 over the sine of x back to the other side. So you might think that by playing these little algebra games, nothing really happens, but we change the geometry of the function. So let's look at x minus 2 sine of x, which is already in Desmos, and then I'm going to graph 2 over x, right? So y equals 2 divided by x minus 1 divided by the sine of x. All right, so we can zoom in a bit, go home. Right, so that's right. So 2 over x minus 1 minus sine of x. All right, so notice that our blue function, which is x minus 2 sine of x, and our green function have the same solutions, right? So I have one solution there, they match. And I also have one solution there in which they match, right? So by rewriting the function, again, we have a very different looking function, right? This green function looks nothing like that blue function, right? So again, like their geometries are different. However, because they're in a sense equivalent functions, they end up with the same solutions. All right, so then they do. So in terms of now this curvature, right? So if we look at our kind of green function back in Desmos, if I choose now a nice value, notice anything between us at 0 and kind of like pi here, which would be like right there-ish, right? So if I pick anywhere between 0 and pi on this green function, any tangent line that I choose is going to be a lot nicer, right? We have something that kind of looks like this cubic. So if I were to choose, say, this value that's just highlighted, it would shoot me off towards that value, right? So by changing the way this function looks, we're changing this issue with all of these kind of like steps and bumps going up to something that has a lot better behavior in this short term. So if we were to like do this thing, right? So if I were to try to use our Newton Raphson calculator thingy here, I'm going to plug in 2 over x, 1 minus sine of x. So let me just open up this thing again. Where we at? Boom, there we go. So our function is now 2 divided by x. And I'm subtracting 1 over the sine of x, the inverse of sine. As we get that kind of funky function again. And if I choose anything again between like 0 and pi, we're going to start to converge on a nice solution, right? So if I plug in 1, I get 1.6561, whatever. I didn't remember that number. I should have. 1.561. Oh, not even close. 656, 1391. So we got 656, 1391. So that gives us a, yes, just let's go home run. A 1.906, 4014. 1.906, 4014. And we can see that we're going to start to converge, right? We're getting closer and closer and closer to this value of 1.895, right? If I did one more, 895, 544, 1.895, 4414. I think that was it. 8955. There's another 5 in there. right? And you can see that again, we're with just that little change of rewriting the function, we get much quicker convergence because of the way that our function looks.